Okay, so we said that we have two main types of data, right? So we say structured data and structured data, right? Now, unstructured data we'll discuss little later, maybe second part of our discussion. And if you talk about structured data, your data which can be saved in a table format, rows and column format, right? So that, there you have data like um, your number, isn't it? Numeric data. This is also called as quantitative data. Okay, the data, quantitative data, which is or quantitative data is something
Measurable,
that can be, sorry,
measurable, like we can
yes, that
measure,
can
count
actually
it.
measure it. Yes, that can actually measure it. Yeah. And then you have qualitative data, which is more like finding the qualities. And there you have, we call it as categorical data generally. Okay. Now, numeric data, okay. Um, so when you talk about um, numeric, again, you have here discrete and continuous data. So numeric can be classified as discrete and continuous. What is the difference between discrete and continuous? Discrete is where it's a countable number of numbers. Countable number of numbers. How many pages in a book, right? What is the population of city, country? Okay. Um, how many cars manufactured? So the answer would be specific number. Okay. Unlike, okay, the continuous data. Now, continuous data, the value is uncountable. It is very difficult to say the value. So the example that we discussed in detail was weight, right? If you take a scale of where there is no decimal point, then the weight would be shown as like integer value, right? 75, 78. It might look like discrete only. But if you add one decimal point, the weight will be 75 point something. If you add two decimal point, it will show you 75.42. If you keep on adding decimal point, the values will keep, it will never show 75.0000. Never ever it will show you like that. You agree to my point? So metric, which actually has uncountable numbers, okay? Yes, there are means to, because see, if I ask you your weight, right, you cannot go on forever, right? My weight is 75.426592. You will never ever stop, okay? So you will approximate it to 0 decimal point or 1 decimal point or maximum 2 decimal point, correct? So such data is called continuous data, where the value is actually continuous. There is no end of the value, right? Your temperature, your pressure, your height, weight, these are all continuous data. Okay. Discrete data is where you will find exact value, 75.4. It will not be 75.44444, right? So, okay. So these are called discrete data, right? Continuous data, generally you express this in the form of ratio, like say 10/3 or 50/3 or something like that. You form ratio, or you create your own scale, right? Scale of 1 to 100 with no decimal point, or with 1 decimal point, or with 2 decimal point. So example that we discussed was, if you take a gold earring and if you put it on a scale which measures only integer value, no decimal value, okay, it will show you weight as 0 kg. Now 0 doesn't mean that it has no weight. Yes or no? So it's showing 0 because we have chosen the scale such a way that we get no decimal point. So your continuous values you will represent in terms of ratio or in terms of scale, right? So scale would mean that if your weight is less than 75.5, you will say 75. If your weight is more than 75.5, if it is 75.51 also, you'll say as 76, correct? So we choose our own scale or we represent. So generally we represent this in terms of scale or ratio. Okay, so your numeric data can be discrete or continuous. Okay, now the analysis that we perform, the high level analysis is different for continuous and for discrete. Okay, but for most of our at least for data visualization, okay, it is still numeric. Okay, we will not differentiate between continuous and discrete. But when we get into probability distribution, things like that, yes, there is some difference there. Did you understand? Are you clear of this?
Yes.
Okay.
Yes, sir.
Yes. Okay. Now let's move ahead to categorical data. Categorical data is not numeric as the name suggests, it's more of a descriptive. Okay. So what we do here is the values are part of a group, are part of a category, right? So when you say gender, so gender value will be part of a category, right? It might have two values or more than two values, okay, like male, female, okay. You talk about regions, north, south, east, west. Now, each value within these categories are equally important, right? Okay, the value, okay, can be one of the categorical value only, one of those category value only. Color, so you define 5 color or 10 colors, okay, or it can be even 100 also, but the values will repeat those 100 only. It cannot be anything like your numeric data can be anything, right? 5, 10, 100, you know, there is no it not belong to a category. But categorical data, okay, when you talk about, I'm talking about structured data for now, okay. So, you know, so categorical data belongs to a group or group of values or categories. Here, again, you can have two types of values, okay. One is called ordinal and second one is called
Nominal.
nominal.
Nominal, sir.
Okay, so nominal data are data where order doesn't matter. So if I take male first or you call female first, if I ask what are the categories, what are the values of gender, I can say male, female or female, male, doesn't matter. Okay, regions, I can say north, south, east, west, I can say south, west, east, north, doesn't matter. So those type of categorical values are part of nominal, okay, where they are there to represent the data. It does not give any significant importance to the order. Ordinal data are data where order is important. Okay, so when you say order is important, like you talk about rating, right? Now rating can be very good, good, average, poor, very poor. Now when you talk about this order has a meaning, right? You cannot say very good, very poor, average, poor, good, right? It has to be in very poor to very good order or very good to very poor, how you represent it, isn't it? So if I ask you what is the grade A, B, C, D, E, right? So you will say A, B, C, D, E or E, D, C, B, A, right? In reverse order, right? So their order is important. Okay, there A and B have a different meaning. A and B are not same, unlike male and female or north and south. Okay, here there is a difference between the values and order is important. When you talk about education level, right? So never gone to school, drop out, you know, below 10th, metric, graduate, postgraduate, PhD, right? So there is an order in that level, correct? So the ordinal is type of data where order is important. We actually follow the order. Make sense? Okay, and your data set, okay, actually changes, or the way it behaves changes based on numeric or categorical, right? Now there are different graphs. We are going to discuss important graphs, okay, and then towards when we do Power BI, we will do some graphs, I'll show you how it is done. And also I will give you more examples. Okay. I'll have more examples for you to practice. Okay. There you will see, okay, we will have almost like 20-30 graphs. Okay. And you can see what kind of values they represent. Since, when we talk of drawing the graph, plotting the chart or graph, maximum you can draw is 2-dimensional. You can't draw 3-dimensional, right? So we will talk about 1-dimensional or 2-dimensional. 1-dimensional is where you have only one data, right? So if you look at this, okay, you will know that the kind of data that we will be plotting can be only numeric, right? One data set, only numeric, or only categorical, right? Or it can be numeric versus numeric, numeric versus categorical, categorical versus categorical, right? So if you look at, there are 5 types of graphs that you can draw, isn't it? So we will see some of the graphs, how if you have to deal only with numeric, okay, which graphs can we draw? So can you give me an example where you are only talking about numeric?
Marks.
Sorry?
Marks, sir.
Marks. Say marks of, let's say, 1 lakh student, right? Let's say board of examination board, state or CBSE, whatever. Let's say they are trying to analyze the performance of student for this year, or they want to analyze the performance of student this year versus last year. Now, when I say this year versus last year, it becomes numeric versus numeric. You are performing, you are measuring performance of this year, which is one data set, versus last year, which is another data set, isn't it? So that would become example of numeric versus numeric. Now, to analyze the performance of this year itself, okay, that is example of only numeric. Did you get the difference? I want to perform analysis trying to compare one data versus another. This year data versus last year, okay, state A versus state B, okay, region A versus region B, okay, male versus female. Now, if you see here, when I said male versus female marks and male versus female, or region versus region, or state versus state, this becomes example of numeric versus categorical. Did you understand this?
Yeah.
Right? I want to perform, I want to
Gender and
measure
marks, sir.
the student marks, okay, of male and female. They say that, okay, this year female has performed better than male. How do you say female has performed better than male? You have 1 lakh data, approximately 50,000 is for girls, 50,000 for boys. How do you say that boys have performed better than girl, or girl has performed better than boys? How do you say that? Right? So we will have to do certain analysis where you look at number versus categorical data. But now let's take this n itself, numeric itself. So let's say you have data like 5, 0, 15, 75, 85, 99, 100. And you have 1 lakh such data. How do we analyze such 1 lakh data? See, if you see 1 lakh data, okay, then it becomes very difficult to analyze, isn't it? Your eyes will be going all over the place, right? I mean, your eyes cannot go to 1 lakh places, right? So what do? We group them into smaller data set which we can easily analyze. Okay, so one of the important graph that we talk about is called histogram. Okay, so we use histogram technique histogram to analyze only numeric. So what you do is, okay, you create groups which is easy for us to create a group okay, number of groups, which is easy for us. Okay, so generally 8 to 12, okay, somewhere around 10 is the best group. So marks will vary from 0 to 100, let's say, right? So what I'll do, I'll create group like 0 to 10. Okay, 10 to 20, 20 to 30. Okay, so on up to 90 to 100. Now I will put the count of each of these student here. How many students have scored between 0 to 10? Okay, between 0 to 10, let's say 15,000 people have scored. Okay, here 12,000. Let's see here 18,000. Let's say here 5,000. Right? So now histogram is a bar graph of frequency table. This table, what I just drew, is called frequency table. What I just drew is called what?
Frequency table.
Frequency table. We are measuring the frequency. We are measuring the count of occurrence. So you will have class here. This is class. Okay, and this is the count. Frequency table. And then if you convert frequency table into bar graph, it's called histogram. So here you'll have 0, 10, 20, 30, 40, so on. Right? You will have a bar graph like this. Okay. So important graph. Okay. And this histogram is important. Okay. We will discuss again in detail in some time. So we are, okay, using this histogram, okay, or which is bar graph of frequency table, to analyze how has been your performance over, say, last few, not last few, sorry. Okay. How has been your performance? Okay. Okay. Now let's say if you get, okay, so uh, um, again, I don't want to get into detail here right away. Okay. But you can actually perform. Not you can actually see this. Let's say if you get a data like this. Okay. Bottom you see. Okay. Let's say you get a like this, or you get a bar graph like this. Which one do you think is better? This one or this two?
First one, sir.
One.
First one is better, right? Because you see, you have more number of people who have scored high number of marks, right? This is 0 to 10, 10 to 20. So you see that number of people scoring higher is better. So when you look at this data set, you'll say, oh, okay, people are scoring high marks. This, you have more people who have failed than who have passed, probably, right? So obviously, okay, so, you'll be happy if you see something like this, okay? But what, and later we'll see that the mostly the trend has to be, okay, something like this. Okay, you do not want more people to score 1900 also, because that way, okay, people will say that this board is easy. Okay, let's say if you get, let's say this is, let's say, state A board, and they say this is state 2, okay, board. Now if you see this, they will see that, oh, this state has very easy questions. Everybody is scoring 90 to 100 marks. Most of people are scoring 90 to 100. So here, okay, this board is probably not doing good. They should increase the complexity
Difficulty
of the
level.
question paper. Okay, and if you look at this data here, this board is not doing good because they are asking very tough questions, and you have more people getting less marks than high marks. This is also not what you want. What we want generally is people to get average marks. Okay, and as you go towards 100, the number of students should fall. Same here. Okay, 50 to 60, you should expect more people to get 50 to 60. And as you go towards left side, lower marks, the number of students should be less. There should be less number who have got 0. And there should be less number who have got 100. Number of people who have got 0 and 100 should be same and should be very less. Okay. This board, you will say that has done well. So if you see a student getting this, so you can be satisfied as a chairman of the board saying that, okay, my question paper was good. Okay, you expect more people on the average as you go on the higher, right? Let's say if everybody in a class scores 95, 98, okay, what does that mean? It means something is wrong with the question paper, isn't it? Let's say if everybody is getting 20, 30, nobody is getting more than 20, 30, that also there's a problem.
Also, yeah.
You want to have one person with 0 marks and only one person with 100
person
marks,
with 90 marks.
right?
Yeah.
That's what. So you want more people to be around 50
Average.
to 60%, right? Or maybe 60 to 70%, whatever, somewhere here, right? Then you'll say that, okay, this year our question paper was
Okay.
good. We did a good job with the question paper. Okay, this is what you want, and this is called as normal distribution, normal graph. Okay, data set is normally, this normal means you'll have more here, and as you go towards left and right, it should become less. Okay, and your mean median mode. So this is the highest occurring value. So this is obviously mode. If you're okay, mode means what? Highest number of occurring
Yeah.
value. Okay, so if this is a tower here, let's say 50 to 60, so 50 to 60 is your mode. Okay, so here also you have data like discrete data, like you have only one value. 50 is occurring maximum number of times, so you say 50 is the mode. But if you have a class between 50 and 60, okay, so what we do in this case, we take the midpoint 55 and we say 55. So when you have a class or interval, something like this, 50 to 60, we take mid value and say 55 is the highest.
Median. Yeah.
Okay. Okay. So we'll stop here for today. Okay. What we did is how to look at numeric data, and we spoke about histogram. Now you read about histogram.
Yeah.
So when you have mirror image, we say normal distribution. But when it is not mirror image, look at the tail, in which side tail is going. In this case, okay, you can see this orange graph, right? The tail is going towards positive x-axis. So, you have x-axis, right? And right side is plus x and the left side is minus x, isn't it? So when you look at this tail is going towards positive x-axis. So we say positively skewed or right skewed or positively skewed. Why positively skewed? Because tail is going towards
to the
right side plus x-axis side. Tail is also your outliers. And in this case, tail is going towards left side. So we say negatively skewed.
Minus
normal distribution is where all the values are equally important. So when you throw a dice, probability of getting 1, 2, 3, 4, 5, 6 are all same. So that is uniform distribution. Okay, we'll get into details like that. But for now, what you understand is if you have only one number to analyze, we can analyze using histogram. See, this is student score histogram. This tells you 0 to 30, 30 to 40.
Which we did, yeah.
Right. Now, okay, what we need to understand is when you draw the histogram, the range should be same. Okay, you cannot say 0 to 30 and 30 to 40. Okay, we should create 0 to 10. If the difference is 10, everything should be 10. If difference is 20, everything should be 20.
Yeah.
Okay, this is good to analyze, but okay, when you actually create a histogram, it should be equally spaced. So 0 to 10, 10 to 20, 20 to 30, the gap should be 10. The difference between low and high value should be 10 in all the classes, all the interval. Okay, so we'll stop here.